come there to present their paper. I am the chairperson in the paper session, and I found that very reputed people, they are using these kind of similarity transformation. There only I started my objection, and I suggest them to derive their own similarity transformations. And they have agreed. Because eta is equal to y means, so how you are going to convince it is similarity transformation? Is it right? Next. So here also some constant into y, it is wrong. Next. Next. Here also same thing, constant into y. Next. For this also constant into, you may observe for the last 8 or 9 papers, every formulation is different from different papers. Is it right? Otherwise, it will not become new work. Each paper is different from different one. But everyone took the same similarity transformation. That's why you are getting so local variable in Reynolds number, Peslet number, Eckert number, Prandtl number, skin friction, and Sherwood number in all these things. Right? So the number itself says Sherwood number, Reynolds number means it must be a number. Then how do you get x in that number, and how do you claim it is a number? If it contains the variable, then how do you claim it is a number? Is it right? Next. This is also with the same mistake. Next. Say constant into y. Next. I took only 10 papers. Look at there. Here I observed, I want to say how we are going to do mistakes while taking non-linear stretching sheet. Non-linear stretching velocity becomes a into x to the power n. For linear, n must be 1. N must be 1 means it becomes meter per second, no doubt at all. A is stretching rate per second, so x denotes length, meter per second. Okay, that is no problem. So, for n is equal to 1, omega is equal to ax, then your unit become meter per second, there will be no problem. When x not equals to 1, it may be fraction, or it may be 2, or it may be 3, whatever the thing, then surely it will become non-linear. Then you see here, your unit will be different. For this, you are going to get like this, and for this, you are going to get like this. But UW means, velocity means it must be meter per second. Then how you are going to claim it as a stretching velocity? Velocity means it must be meter per second, but you are getting different from meter per second. Then how you are going to claim it as a meter per second? That's why we should take care. Next. So, next. So we took one formulation and we derived a new similarity transformation with my students. There our stretching velocity for nonlinear case becomes UW is equal to like this, and for U infinity is equal to like this. You can check out there, the resultant becomes meter per second, it is meter per second. Similarly, means we balanced the variable, we balanced the equation with appropriate transformations. Next. So this is the formulation. So what we did earlier, same formulation, we took the same formulation and we derived the new similarity transformation, and so we derived our own similarity transformation. Our similarity transformation obtained like this: y by x to the power 1 by 3 into some constant. Means it includes both the variables. It includes both the variables. Then your claim will become, appropriate. Otherwise, so your claim is not appropriate. So we derived with this similarity transformation and we obtained the solutions. So we obtained the solutions, and there we find the results. Here, these are the earlier work, and this is the work with analytical method to compare. To compare analytical method with some appropriate restrictions. With some appropriate restrictions, we solved the equation analytically, and we compared the solutions with previous work. we found that, so lot of error in the solution. You can find lot of error in the solution. Next, similarly here also, the error with Simon. So, and we compared with the appropriate work also. Someone did the appropriate similarity transformation. I told you about 90% people doing mistakes. Remaining 10% people are there, say they did well. We compared with the results of those people and we obtained the very good agreement with those people for some restricted assumptions. Next. So, look here carefully. This is very important thing. With eta is equal to some constant into y, you are going to get something, Nusselt number, you plot the graph. And you are going to climb, you know the nature of Nusselt number. Here you can find the same nature, what you want, but here the opposite nature is there. Why you are not climbed here, why only here? Means same graph giving different natures. Then how your climb going to be correct? Is it right? In half of the graph you can find the appropriate nature, but remaining half of the graph gives opposite nature. But you selected only what you want. Why will you leave the remaining part? But using appropriate transformation in the left hand side, we obtained the same graph but with appropriate nature of the Nusselt number. So that is the difference. So you can find what is the importance of selection, derivation of similarity transformation for your own differential equations. Next means conclusion means kindly derive your own similarity transformation for your own formulation. Don't follow any others similarity transformations, because I am stressing each differential equation have their own, unique similarity transformation. Each differential equation have their unique similarity transformation. That's why my suggestion is you have to derive your own similarity transformation for your own work. Please don't follow any XYZ, including me also. Okay? Next. These are some references what I took in the previous case. Next. Thank you very much. So this is what my intentions is to share with my research community, because we are all doing with the same field means, just like one family. In that family, mistakes should not happen. Already we did the mistakes and I realized that I did the mistake. Same mistake should not carry forward to the younger generation. That is my intention. That's why I started this work. If you have any doubts, please feel free to ask me.
Yes. If you have any doubts, you can ask now. Now it is open for the discussion. But even still, if you have doubts, you can mail and you can get the clarification.
Of course.
Sir, the first equation you have shown, a very simple equation. Can you give just for that equation example, like how you have chosen y and eta?
Sure, it will take half an hour.
Just as a statement.
No. So take
Like,
x. Sure. So instead of x, you can take, represent it as some scaling transformation. S is equal to some epsilon into x power some a. Okay. Similarly.
For a, t power b, like that.
Like that. Then substitute those in the, find the derivatives with respect to those and submit it in the equation as well as in the boundary conditions. Those you can find the relations between A, B, C and those constants. Okay.
That is non-dimensionalization, what physics is.
Yeah, of course. Okay. So there you will find the relations between A, B, C and system of equations to A, B, C. Then solve those equations. Sure, you are going to get the values for A, B, C and all those things. Then substitute the values in the original, what you took earlier, in those equations. they will become your similarity transformation.
Okay. Sir, like suppose your partial differential equation is uxx equal to utt. In that case, can I take u is equal to e raised to eta?
Sure, sure.
Eta is because e will get cancelled.
Yeah,
Then
of course.
eta is equal to x raised to a, t raised to b, like that?
100%. I too agree with you, but it is wrong.
Okay, that's what I wanted
Why?
to say.
Why? Because you should not see only the equation. You have to see all the necessary initial and boundary conditions. Yeah. U is equal to e power ix into some f anta tagoltiri. Then substituting in the equation you are going to get ordinary differential equation. But same similarity transformation has to satisfy your initial as well as boundary condition also. If it satisfies both, then no problem, you can. Then no problem. That is just by inspection method, not appropriate. Is it right? Just by inspection method.
Your paper has details in this similarity transformation.
No. We have not provided details in any of our papers. Just we have given only the new similarity transformations in our paper, what we derived, and all the thing calculation. So ನಾವು ಬಚ್ಚಿಟ್ಕೊಂಡಿದ್ದೀವಿ ಅಂತ ಹೇಳಿ. ಯಾಕೆಂದ್ರೆ ಅವಾಗ ನನಗೇನು ವ್ಯಾಲ್ಯೂನೇ ಇರಲ್ಲ ಅವಾಗ, ಹೌದಿಲ್ಲ? ಇಫ್ ಯು ವಾಂಟ್ ಯಾಕೆಂದ್ರೆ ಎಲ್ಲರೂ ತಪ್ಪು ತಿದ್ಕೋಬೇಕು ನಾವು. ಇಫ್ ಯು ವಾಂಟ್, ರಿಯಲಿ ಯು ವಾಂಟ್, ಸೊ 2 of my students are working, I already told you. So you can send your student to her, or so they will come to here, so you can provide food and shelter, all those to my students. Sure, they will teach how to calculate. There will be no problem. And ಅದರ ನಾನು ಮಾಡಿದ್ದು ನನ್ನ ಹತ್ರನೇ ಇರಬೇಕು ಅನ್ನೋ ಕಾನ್ಸೆಪ್ಟ್ ಎಲ್ಲೂ ಇಲ್ಲ. ಯಾಕೆ ಅಂತಂದರೆ ಅದನ್ನು ತಿದ್ಲಿ ಅಂತಲೇ ಇವತ್ತು ನಾನು ಲೆಕ್ಚರ್ ಕೊಡ್ತಾ ಇರೋದು, ತಿದ್ಕೊಳ್ಳಿ ಅಂತಲೇ ಲೆಕ್ಚರ್ ಕೊಡ್ತಾ ಇರೋದು. ಅದು ತಿದ್ಕೊಳ್ಳಿಲ್ಲ ಅಂತಂದ್ರೆ ನಾನೇ ಅದನ್ನ ಬಚ್ಚಿಟ್ಕೊಂಡ್ರೆ ಮತ್ತೆ ಮೋಸ ಮಾಡ್ದಂಗೆ ಆಗುತ್ತೆ, ಹೌದೇ ಇಲ್ವಾ? ನಾವು ವಿ ಆರ್ ಓಪನ್. ನಿಮಗೆ ಬೇಕು ಅಂತಂದರೆ ನಿಮ್ಮ ಹುಡುಗರನ್ನಾದರೂ ಅಲ್ಲಿ ಕಳಿಸಿ, ನಾವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಕಲಿಸ್ಕೊಡ್ತೀವಿ. ಇಲ್ಲ ನಮ್ಮ ಹುಡುಗರನ್ನ ಇಲ್ಲಿ ಕರ್ಸ್ಕೊಂಡು ಬೇಕಾದ್ರೆ ಕ್ಲಾಸ್ ಮಾಡಿಸಿ ಅವ್ರ ಹತ್ರ, ಅವ್ರಿಗೆ ಫುಡ್ ಆ್ಯಂಡ್ ಶೆಲ್ಟರ್ ಏನಿದೆ ಕೊಡಿ ಅವ್ರಿಗೆ. ಸೊ ದೇವ್, ಯಾಕೆಂದರೆ ನನಗೆ ಬರಲಿಕ್ಕೆ ಕಷ್ಟ ಆಗ್ಬೋದು. ಯಾಕೆ ಯು ನೋ ದ ಅಸೈನ್ಮೆಂಟ್ಸ್ ವಿತ್ ಅಸ್, ರೈಟ್? ದಟ್ಸ್ ವೈ.
Thank you, sir. Because so far I had taken only ordinary differential equation like for fractional, but PD, because of this problem actually, when we have to PD, we cannot solve by numerical method
Yeah,
very easily.
100%, I told
So
you.
we have to convert to OD. So
Yeah.
to convert to OD, it should be proper. So because of that.
Yeah, of course.
Okay, thank you, sir.
Okay, thank you very much. Bye.
So I would like to invite Prasanna Kumar sir to hand over a memento as a token of gratitude.
ಶೇರ್ ಮಾಡ್ತಾರೆ.